Cool. Hello, everyone. Welcome to another stream. How's it going? So, today we're going to be carrying on with the grass. We're just going to get it looking more like a field of grass today. That's the plan. So, we have essentially a bunch of grass blades being spawned on the spawned via a compute shader, obviously running on the GPU. It's just an 8x8 grid. And we're simply just then last stream we got the UV working, so you can see it here, right? You can see how there's sort of a black corner, then a red, and then a fully green corner and a yellow. So these are the UV coordinates, right? So we've got that working now, and we've kind of got some sway going on as well, just to sort of show that it's not static. But we can make it more like a proper wind kind of thing in a bit. So I think what we want to Oh yeah, sorry, and we'll sway in here just to show that the UV kind of works still, basically, while moving it. But so the first thing we want to get done today is we actually want to make the shading work. So we've already got a material written up, procedural material all written up in code. We just want to get it signed. And then we can hopefully move on to filling up this whole plane or something. Hang on a minute, I've just done a silly. Right. Fill up this whole plane or something with a bunch of grass, or maybe just populate this 8x8 with more grass blades and sort of just have them at different rotations and things and just see what's the best we can do. And then we can, then I'll probably want to park it there because the objective for this piece of work was just to get the materials working. Basically, that was the plan. And we've achieved that. So I want to go on to going back to getting some cubes and just testing a few different more materials before we make meshes work, which would be super cool. But yeah, any questions, feel free to ask away. So start with a quick prayer and then we'll get going. So our Father in heaven, thank you, Lord, for this day. Thank you for blessing us with another day to do your will. Thank you, Lord, for protecting us, giving us more time on this earth and protecting our family. You know, none of my family died during COVID, so I thank you for that. And I pray thanks for everyone else's family who's still here. You know, so thank you for my son and my other child on the way. I thank you for my wonderful wife as well. We thank you, Lord, for our spouses and the children that we have in our lives. And Lord, we just want to pray for you, Lord, to be present here in this moment, Lord. Protect us from any plans of the enemy in our lives. No plans of the enemy shall prosper, and no plans of the enemy shall win in our lives. Let your will be done in our lives to its fullest. And, I pray for each and every one of these souls that come by today, they see the presence of God, but more importantly, that they, before their time ends, Lord, I pray they accept you as their Lord and Savior. They don't end up eternally separated from you. Thank you, Lord. I pray you help me, Lord, set out to achieve the things we want to achieve and maybe do some more interesting things too. And, I pray you help me find the shape of this project and how it's supposed to be and how it's supposed to work. Don't let me go down any dead ends that don't yield fruit. Help me, Lord, though yield fruit. Find directions or find that straight and narrow path. The ones that lead me into the correct things I need to learn and understand and things I need to achieve. Thank you, Lord. In Jesus' name we pray. Amen. Cool. So, let's keep this window open because I guess it's just going to be hotcode reloading this thing from now. So, we've got a deferred shading pass with a 4-layer visibility buffer, so we can do order independent transparency. So we've got a triangle instance thing. So it's got like an instance index and a triangle index, and it's also got a kind. So it's got a single bit for a kind at the moment. It could either be a mesh or a grass blade. So currently the mesh does the shading here. We need to also do our own shading as well. So let's figure this one out. Oh. Do 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 do. Okay, so let's start off by bringing the shading out where it's supposed to be. So we've got the UV working. You can see it being colored right now. Yeah. So nice. So we need to populate this surface position. Actually, this is kind of wrong. We found out that the depths don't actually provide a value that we want, unfortunately. Yeah, so I need to look into that. To do investigate why depths does not hold a precise value to the surface of the triangle. So currently we just reverse triangle again. Yeah, but this is kind of okay. But then if we don't need it, we don't really need to be reading from the depth value then. And we could theoretically just read from the object. So it was this and the barycentric chords. So there's all these dot products. They're not that expensive, but there's 3 dot products here instead. There's a cross, which doesn't exist. A couple of crosses. They're kind of similar to a dot product really. It probably doesn't matter. It's just a bit weird though that, yeah, performance-wise they're about the same. And if we only had a depth value, we would just be computing this p-value. Sorry, if we had a depth value, we'd just be computing this p-value and then calculating the barycentric coordinates. In world space, right? But then we don't have it, so we just do a reverse triangle and it's basically the same. So yeah, there's that. Basically, it's a bit strange. Yeah. But then again, it doesn't really matter. Because reverse triangle looks to be cheaper than calculating barycentric coordinates anyway. When reverse triangle returns barycentric coordinates 2. Something like that. Right, anyway, so now we can cut that short. So the basic idea, we want a few things returned. Well, the surface position. Normal in wall space, tangent by tangent. So it's just these things for now. Now, yeah, last stream we did this, right? Then, so we don't need this debug stuff anymore. This is pretty cool. We built this debugging thing so we could like hover over and see where the sphere is and then see the triangle, the vertices for the triangles. It was pretty cool. Pretty nice. But anyways, don't need that anymore. Now, yes, here's the barycentric coordinates. Oh, does that not want to compile? Okay, we can't see it. It's fine. We don't care anyway. Right, so this is what's known as a UV. So we need a UV as well. So UV will be a snorm, basically. Sine norm valley. So how do we calculate one of them? Well, we need a surface position as well. Do 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 do. Yeah. So that will be a surface position world space equals ray origin world space plus ray direction world space times by hit dot t, something like that. So that would be, yeah, so unorm snorm, sorry, UV snorm would be just be position local space. Then we've got tangent. Well, we missed normal, to be honest. But yeah, what would we do for those? They'll be in world space, wouldn't it? Yeah. Oh, what should we do? We could go local, world from local, basically. Yeah, I don't think you're interested in scale, just the rotate. We could do that. Yeah, we'll need that. Sorry, 2 seconds, BRB. Yeah, how's everyone doing? Hope you're having a good day so far. Oh. Okay, so tangent and normal and all that. So we might want to add some function which helps us just do the rotation or something. So there is this position thing, right? So we have one instance. You do want to apply the rotation. So scale, then rotate. So this is rotate here. Right, so it's after scale. So be pause world space equal whatever this thing is. Instance pause world space, yeah? Nice. So yeah. So we basically would like to rotate a you can probably call that value at this point or vector. Now oh, so we would like to rotate vec3 1 0 something like that, and then bitangent would be the y, then the normal. Yeah, I don't know actually if we might have to switch this up into being a full-on matrix at some point, because, well, maybe not a full-on matrix, but some values which you would then compile into a full matrix, because rotation, like you're going to spawn grass on like an edge of a cliff or something, right? You know, on a hill. So like, yeah. Anyway, future Henry problem. For now, this does the job. So we've got those ones. I'm happy with those. So now all we need to do is do the same thing up here kind of thing. Now the vertices, though we don't have them, for the mesh, where do we get those? Yeah, they're currently just oh, hang on a minute. They're currently just it's just a box. So yeah, we can get those. And then reverse triangle. And then yeah, move them into old space. Then reverse triangle. Yeah. And that should get us basically what we need, I think. Because we'll be going back to using this code. And then because you're doing a sort of a, you could, yeah, I think we did it with a triangle strip. So what we do is like a mesh. This one. No, yeah, they're from the CPU side, the vertices. Right, what have they done with They're done as a strip, aren't they? Still. Yeah, they should be using triangle list. Oh, it's not very nice. Yeah, I think we'll just do depth at the moment, and then to do ray trace. Then this one, we could probably take the triangle index and somehow work out like what face you are or something like that. And then from which face you can figure out which. No, but if you did the reverse triangle, you could figure out the. No, we should bring back the reverse box code again. Yeah, we'll do that. Like, when we need to render a cube again, we'll do that. Okay, where was we? So, material layers. That's another thing as well, actually. How do we do that? So for the grass, this is not very good at the moment. Yeah, so I think what we can do, man, I can't wait to get back to meshes. It'll be cool. Sorry, get back to the materials. I've got some more ideas. Cool. Then these ones go here. Now I wonder, is there a null one of these? I think there is, you know. Invalid, this thing. I think we can just do that. Although, yeah, we have to do dot bit filled 0. Yep. So then, thankfully, inside the grass instance, we have a material, I think. I think it's in there. Yeah. See? So that's cool. I think that's it. Let's try it out. Well, it's got a whole bunch of errors. So nothing called, for some reason in the shading structure, there's nothing called normal. Surface, normal, surface, tangent, surface. Alright. Hang on. Cool. Nice. Oh, it's far less stuff. So 80, no matching one called rotate. Right, because you need the instance passed in. This looks a bit fishy. 57. Then 94. Alright, it's this detail grid thing. I'm not really a fan of that anymore. I think we've got some different ways of doing it now. Cool. Well, we're getting some progress here. We're seeing that line in the middle. I did make it white. That was very true. The top, however, is not being shown too well. I don't know why. I thought the top was known as 1, in the UV space. So we can test that out. We can say if is mouse at yeah, so see here, I hovered towards the top and 0.94 on the Y, so still, yeah, it does go up to 1 right at the tip. So, it's interesting. But yeah, it is running the right material. The colors are a little crazy. Maybe because of the brightness. I'm not sure. So grass blade material. Right, why don't we just set it all to being green? Or red, sorry. Right, so the whole thing to red is still is a problem. So that means then something else is going on. You notice there's a bit of curviness going on as well to the normal. Which is kind of cool. But yeah, let's put that back. It's strange it just stops. Is there like a... Right, this is this inset thing, isn't there? That's why. I think this is it. Yeah. Cool. Right, that is because... Yeah, so this is like on the geometry material. We... This is like... What is it saying? Yeah, it's basically moving it inwards. No, I think I'll make that belong on the brick, to be honest. And we can, yeah, I wonder how much this we want to keep. Let's comment it back out for a minute. We'll come back to this when we do proper We'll do materials again starting tomorrow. Okay, so that's good. I wonder why my hotcode reload is not working. Since I changed this header file, it should change this. Can I investigate that for a minute? Like in the build, we've got all these like these D files everywhere, right? So they're the these ones. Hang on a minute, let me secret this for a minute. Cool. There's no secrets. Scene shade.d, right? So that's what the compiler outputs, the GLSL compiler. So its dependencies are, is there the material one in there? Yeah, materials.h. So let's check my timestamps. File, this is just my build system thing. So I guess graphics materials. It's got a timestamp in there, that looks alright. Yeah, I don't know why that doesn't want to, I might delete that file. Yeah, let's do that because I'm trying to like change a header file and it's not causing a rebuild. Kind of annoying. Let's try that. It is a bit bright, this green, not gonna lie. Right, so we've got like a... Yes, if I change this... Yeah, good. Right, yeah, this one is going on with the build system. Hotcode reloads properly, good. So what else we've got to change? Yeah, let's investigate that normal thing that we did. The thing is bending the right way. Like if we were to say replace this with a... So here it's just flat. Pointing one direction down the Z. And I guess here it points down the X now. Yes, it's pointing directly towards the sun, which is that way. But yeah, this makes it curved. So you can see it, the edges pointing towards the sun, it sort of gets a bit of the light there. Did we put maximum curviness? I forget. Yeah, we did. Right, so from the CPU side is where we defined the grass blade material. Those were the colors, they're a bit bright now that we see it, but okay, I guess that's fine. They had like a veininess, so you can see the vein going through the middle. We made the vein white for some reason. I don't know why. Yeah, I thought we picked grass colors. We picked top and bottom. That's a good point. Then we picked some glossiness too. So let's make the glossiness 0. That's meant to be really rough. This is meant to be really glossy. Anyway, so why is there any... Can I pick like a bottom color or something? Like, let's get rid of the vein. Hang on. That's without the vein? The vein is causing our problems. You see that's a much different color. And also, hang on a minute, why? Hmm. So let's get the vein color. Just white, isn't it? Yeah. So we're trying to smooth step, and I guess it goes too far. So the ABS of shading UV though is like -1 to 1. Then yeah, shading UV dx is -1 to 1. We ABS that, and so 0 to 1, divided by veininess. How much veininess did we have? Well, veininess here is 0.1. Yeah, that really makes the color look very different. Is smooth step in the wrong place? I think so. Sorry, I think the parameters are in the wrong place. Edge, edge, and then type. Yeah, maybe it's not smooth step that I'm trying to use. Is it lerp? Yeah, I think it's lerp. I think. Kind of. Although, like, so also this bottom color, top color thing, like, what is going on? It seems very. Oh, yeah. So there's a darker color at the bottom, lighter color at the top. Nice. Although we shouldn't probably need to have that, but we do anyway. Doesn't matter. Cool. Now. This veininess thing. So when you're shading UV, so you know, X on shading UV is right. Let me write this down in a comment because if not, I'll forget in the future. So this is in a range. Is in a 0 to 1 range. And X is in a -1. And that's just because it is in. That's just because of the way the vertex shader just does it. Like the bottom of the blade sits in the middle of the local space, right? -1 to 1. Because it just made it easier. Now, the edges do show up as black. Veininess is 0.1. So, oh, it's gone over. That's why. So you need to clamp. Yeah, so you need to make sure you clamp between 0 and 1. There you go. So now it's got that vein going down the middle, but it's kept the original colors. Cool. Yeah, I'm not sure those are the colors we want, although, yeah, it could just be because the scene's like stupidly bright. because it's, yeah, there's some, all right, here's the, maybe. I guess we can always go to the settings and bring down the exposure. No, okay. Nice. Yeah, I forgot we did that auto exposure. It's cool. I like it. Got the bias in there as well. Nice. So now we've got the material shading, which is great. We can now, I'd like to go back to the emit and let's make it such that it's more of an even spread. Hey, what's she complaining about? Nothing. Oh, it ends at 30 still. It does, doesn't it? I like a bigger tip. It's true though, isn't it? Yeah, so we did 4, 8. I guess 12, 16, 20, 20, 24. Now I should have more of a bigger tip. Yeah. All right. Hmm. 28, 25, 20, 15, 11. There you go, a bit more of a tip now. Cool. So right, now let's make it such that they can have some kind of rotation. So based on the distance, yeah, this coordinate thing here, we can pass it into, so we do a PCG hash. So we take the flattened index thing. So flatten 2D, I think it's called. That's it. Yes, the width is 8. So PCG hash 32 index. And now we've got some rotation that we can do. We can say and so many bits with it. We'll divide by U32 max, cast it into a float, and then we just need to like times that by pi times 2. Yeah, so you've got different rotations now. So the next problem is in the shader shared header file. The the wind is applied in local space rather than in world space. So yeah, I don't know. We should probably have like a bend. Let's bring this out a bit. Yeah, the rotation is fine. I don't know how they did their in Ghost of Tsushima. They did the bending. Like, you need to have some kind of like resting position for the grass blade. I don't know how we want to define that. Um, and then the resting position for the grass blade maybe. And you definitely want to do more grass blades as well. So they're not just a grid, sort of like to a. Let's see if we can watch that video. Don't know what's happened there. Let's get the headphones on. Yeah. I want to pull the blind down.
And I'm a graphics programmer at Sucker Punch Productions. This talk is about the procedural grass systems we used in Ghost of Tsushima to achieve our art direction goals. A quick note, barring some unforeseen circumstance, I'll be available in the live Q&A chat for this video when it's presented, so feel free to put any questions you have during the talk there, and we'll answer them as soon as I am able. Ghost of Tsushima is set on the island of Tsushima off the coast of ancient Japan, and from early on, one of the primary goals was to portray the natural beauty of the island. This meant
Alright, so
shows the player where to get material data in our pixel shaders. And their parent.
So they go with the computer shader first, then the data pipeline, then the vertex shader. So I think we're interested in the vertex. There's the data pipe, is the vertex, right?
Between the two logs is a little bit tricky. Since our grass can have very high curvature, there can be popping when we move to a lower number of verts. To alleviate this, the high log blends towards the low log as it nears it.
Interesting.
It's also worth mentioning that the low log tiles are twice the size of the high log tiles. So vertex positions along the blade are trivial to calculate.
Right, this is a Bezier curve.
Now that we know which type of grass blade we are and relevant details about our vertex, we have to decide where our vertex goes in world space. The shape of each grass blade is a cubic Bezier curve.
Yeah, this is it's like a couple of minutes of listening.
This has a lot of useful properties. Vertex positions along the blade are trivial to calculate. The derivatives are also trivial to calculate, which makes our normals very easy to determine. And the control points give us a lot of control over the shape of the blade. This makes it easy to animate the grass and also have lots of different shapes of grass. But where do we place our Bezier control point?
Hang on a minute. My normals are probably not right. Yeah, the normal, as they bend, the normals are not right. Yeah, we need to fix that.
To start, we decide the position of the tip relative to the base. This is controlled by the tilt parameter from earlier, as well as the facing. Next, we define the midpoint, which is controlled by the...
There was a tilt parameter we skipped. Oh yeah. So, probably here. Those were 11 minutes, 9 seconds. So they did facing, which is 2 floats.
And pushing it out of the way, the position of the camera, and more. 3 floats for position, and 2 for the facing direction of the blade. This 2D facing vector determines the direction the blade of grass is pointing. We put the strength of the wind...
I don't know why that can't just be one, like that's what we've done, just a rotation. But then again, yeah. Or are they doing 2 direct? Oh, sorry, yeah, it's just 2 floats, isn't it? Yeah. I guess they just do it across a flat plane, but I don't know why they need 2 floats.
At the blade's position, which drives animation. We place a per blade position based hash that drives various things on the blade, including animation. The type of grass it is, which determines parameters and are different. The position of the camera and to the wind in a second here. And lastly, various parameters for controlling the shape of the blade. These parameters are influenced by a per blade hash, what clump the blade belongs to, the wind, the slope of the underlying terrain, things moving through the grass and pushing it out of the way, the position of the camera, and more. The way the blades interact with those things are all driven by artist-author parameters and are different for each type of grass.
Okay, so no mention on tilt, just like, all right.
With this shared clump,
Let's talk about, all right, let's go back to the 11 minutes 9 seconds.
parameter. If bend is 0, the mid parameter from earlier, as well as the facing.
Right, so the tilt here, I guess it was just described right here then. So tilt just describes, so the maximum it's going to be able to do is the position will be up here then. The tilt one will be up there, so it's just a diagonal type of blade with some curvature, I guess, like that. So at minimum will be there, but it can go all the way down there then. I think that's what it's saying.
Our Bezier control points. To start, we decide the position of the tip relative to the base. This is controlled by the tilt parameter from earlier, as well as the facing. Next, we define the midpoint, which is controlled by the bend parameter. If bend is 0, the midpoint lies along the line between base and tip.
Hey, Rumil, it sounds expensive to me. Thousands of Bezier curves. How do they manage to optimize that, I wonder?
Values larger than 0.
I don't know. Bezier curves are quite, not really. Like, you also remember it's on the GPU. It's quite inexpensive. Plus, they're doing it in the vertex shader, so there's like, it's not doing it per pixel.
Push it up and away from that line. For split blades, we keep the same general shape, but push the two blades apart. This keeps them facing the same general direction while still increasing coverage. Now that we know where our control points are, it's straightforward to determine our world space position for our vertex. We take our 0 to 1 value that determines where we are along the blade and feed that into our Bezier curve function. Next, we take our facing direction, flip the x and y, and negate 1 to find a normal orthogonal to our facing. We step our vertex in the normal's direction a distance depending on the width of the blade, calculated in the compute shader, and scaled by where we are along the blade.
All they did in the compute shader, right?
We want to taper down as we reach the tip.
Did they pre-calculate the vertices in a compute shader? I don't think so. I think maybe you just spoke wrong.
Next, to find the vertex normal, we find the derivative of the Bezier curve at our position and cross it with the normal we just found.
All right, the derivative curve.
But how do we make it move? A quick aside about our wind system function. We keep the same.
Okay, so I reckon, yeah, you want a Bezier curve. Well, why would you want it? So yeah, it just basically defines. Let's see this midpoint thing again. Yeah, the tilt, you can have more tilt, and it'll go down there. Yeah, and then how's it? The midpoint is about moving.
But where do we place our Bezier control points? To start, we decide the position of the tip relative to the base. Next, we define the midpoint, which is controlled by the bend parameter. If bend is 0, the midpoint lies along the line between base and tip.
If bend is 0, it lies along the line between base and tip. Ah, right. Okay, so actually it lies on the line. But then if it's not, it moves away. So it's like, but why is it at like, interesting.
Values larger than 0 push it up and away from that line. For split blades, we keep the same general shape, but push the two blades apart.
Seems like it's at 6, 6, or whatever it is. Yeah, 0.6 or whatever. Weird. Okay. Makes sense. So it's a bit further than halfway then. And then push your way to a curve. So the more... Right. Okay. Yeah, okay. That's pretty simple. So that would be... That would just be a standard Bezier curve. There's two ones. Right? There's the quadratic one, which has like two control points, and there's just a... Which ones are there again? So... You know, IQ has some of these. IQ, ray intersection. Let's do that. We can get his website. We get it all the time. He's got a quadratic Bezier, I think, somewhere. Oh, bounding boxes around a Bezier. That's what I was thinking. Yeah, because he has that bounding box stuff. Maybe not. There's more time. I actually don't know how to use that tool. I've not really used it, but I see it's quite useful. Yeah. You basically plot. Yeah, you plot things on it. Right, I don't know if he has any Bezier curve functions. So right. Right. We want a 3D Bezier curve. It is the cubic or right, so we could just try this one, give it a go. P1, P2. This is cubic, isn't it? Can we get like the quadratic is just combines two of the points into one, you know, P1 and P2, those are the control points. P3 is the end, P0 is the start. Yeah, so I guess let's take that for future, but the basic idea is drop it in here somewhere. Right, what about a... That was cubic. What about with 3 control points? Isn't that called quadratic? Right, that is what quadratic one is. Cool. Yeah, essentially it's just a bunch of lerps basically, right? It's a lerp between... Yeah. Cool. Right. Bezier 3D quadratic and then Bezier curve cubic. So yeah, that's quite cheap. That's not very expensive, is it? There we go. So then in the vertex, well, it's on the vertex shader, so All right, we just did a sort of wind thing here. We can always just ignore that. So a bendiness. Yes, there's this sort of like local space thing. There's a scale, that's for sure. And then this isn't really going to help, is it? In action, let's take a look. Hang on. Can I pop that open? Yeah, see, this is probably a demo of the Bezier curve. Like a tree root. Boom, boom, boom. Well, this is cool. Because I'm looking at doing procedural wood anyway. Like, this would be handy to know. It's by IQ, of course, isn't it? Yeah. Cool. What's it like to do the texturing? Oh, he's got the texture here. Damn it. Right, so he's basically just got a UV. Hmm. Yeah, so what he's done is done probably like a cylindric, a capsule or a cylinder type mapping, I guess. Just a guess. Cool. Onto a flat one. Right. Cool. Nice. Awesome. All right, so yeah, let's get rid of this wind thing. We could, you know what, we could do it. Like, how will we know? Yeah, I think the wind might just rattle the thing. I'm not sure, but anyways, let's just get rid of the wind for now. Oh, does it not want to work? Every now and then it breaks, which is a shame. Right, here we go. Okay. Now, so that Bezier, we've got this local space position. We probably want to have a few more parameters. Like we probably want to know, like, you know, as we were thinking, or sorry, as the thing was saying, it was like there's a tilt where 0 is is diagonal Yeah, it makes stuff really diagonal all the time, though. You can't get something that's completely straight up. Can you really? Yeah, I'm not really sure of yeah, maybe tilt should be describing yeah, tilt of 0.5 should get you over there. Tilt of 0 get you all the way down there. Tilt of 1. But tilt 0 has you all the way up here, so there's no tilt. And as you go to 0.5, it gets you over there, then down there. But it will be more of a curve, I guess. So, yeah, tilt. And the other one was, what was that other parameter? The other parameter was known as midpoint. That's just curviness, isn't it, really? But then, so, a tiltedness, then you naturally want curviness. So you don't have a sort of a diagonal blade of grass, right? Just sticking really straight. But you might want it just a little bit of a curve, or maybe lots of curve. Would you ever want that? Maybe. Yeah, maybe you do want a midpoint thing, so you'll call that curviness. Tiltiness. Tiltness. Um, yeah, curviness. Yeah, that's what you want. So when you fill in this, it's going to be filled in from the GPU. So we'll just say tilt. Now tilt's just again going to be a random value. We could do the one with that state, or is it at? Right, so again, tilt is going to be something like that as well. Then what else would we get? There's that we call it curviness. Another one. Cool. Big fan. So when it comes to defining the local space position, now we should have a tilt and a curviness, and we have the Bezier curve function. So essentially you want to define, you got your P0, which will obviously be 0, 0, 0. And so your Y would be your T, which goes along that Bezier curve, basically. But I'm not sure. Yeah, X will be, yeah, so T. Yeah, so you're just computing. Then a vector, which would be known as Y, YZ. So that'll be your Bezier curve. I guess what you actually want is Bezier curve 2D, not 3D. So I think that would then be Okay. So we'll to get this one as well. Nice. Cool. So we want the quadratic. That's a little bit cheaper. So we'll just do a Bezier quadratic. We need to find our P0 control point. That's just 0 hard coded. Your P1, which is the control point, just get. I guess they're all called control points. But yeah, so these define a line, and the other one defines like is that midpoint basically. So this one, we need to decide based on the tilt. So I'm thinking it's basically, if we were to draw it out, you've got a little graph, and I'm thinking, 0 tilt is just going to go directly up. A tilt of 1 goes directly to the right, maybe. Then obviously 0.5 goes like that. So effectively you're just defining, that sine cosine, isn't it? So yeah, sine cosine. So it'll be like tilt sine instance tilt cosine instance tilt. So obviously when tilt is 0, cosine is 1. Cosine tilt is 1, making y 1. Right? When tilt, well, this is a little bit wrong, right? Because it's in pi times tilt times pi, so we'll call it angle. So times pi divided by 2, I think. Right? Because a pi is half a circle, but we just want a core of a circle. So there's that. So yeah, when tilt angle is a quarter, is half a pi, passing that to sine will give you a value of 1, so it'll be x on the 1 on the x, and then 0 on cosine. Cool, so then the midpoint would be, they did like 0.6 along that. So essentially you want to say you got this P1, which is like a lerp between those two 0.6. The compiler should optimize that as well. And then essentially you want to take the you could do a lerp, or you could just get a dot product. You could do a dot product of a normalized vector going in that direction, and then you can do a, I wonder what would be better. Sine, you do sine cosine, that's for sure. But then, yeah, that's what you want. That essentially has got you the vector anyway. Yes. So if we've got a vector going that perpendicular, it's already got you the perpendicular vector. It's just going in, doing a Let's call it perp. So perp would be vec2 p2 dot y p2 dot x. Now he's got to figure out which one gets the negative. So I think because you're going left, like your y is already up. Oh no. Yes, you need to negate. Hang on a minute. The x channel, the new x channel, so it goes the other way. So it goes backwards. So then yeah, and then we can control how much to shoot the midpoint off by that much. So what else do we need to do now? It's called a curviness. So curviness should describe, like, so if you have a diagonal, you've got a vector going that way now, a normalized vector, I think. I think it's normalized. Is a vector made with cosine and sine and cosine a normalized vector? I think it is. Let's ask the AI, which will probably lie to me anyway. Yes, it is, as long as the angle is the same for both. Right. Cool. That's what we need. So given that, so with this normalized vector, right, so obviously it's kind of a bit bigger than that, but it's that direction. It's not starting here, it's just a vector that's going in that direction. But we're going to take a control point, which is somewhere along here anyway, and offset it by that much, yeah? Let's just imagine that control point's here, that midpoint. Now, it's kind of 0.6 along. So we, yeah. So 0.5, we'll put the thing up here. And that would create, I think the maximum you want to go is by 0.5. So the curviness you'll get with a point there will be something like this. Is that the maximum curviness? I don't think you want no curviness. Right, but you can go even further and you will get maybe something like a... Right. So I think what you kind of want is that curviness value needs to be remapped into a instance curviness needs to be remapped into something where it's probably snubbing out it so it's not really a straight line, such that it does at least do that, right? So you probably want to do times 0.6 and then offset by 0.2, meaning you got a value going from remap to, so it'll be a 0.2 to 0.8 value, right? Yeah, I think that's what you want. So now when we have curviness here, we're doing our Bezier, sorry, the P1, that midpoint, that control point that we're going to define. P1 is going to be a, we're going to add on to that point perp times curviness. And then those should be our control points. So it'd be P0, P1, P2, and then you need a T, I think, right? You just need a cup of tea. So the cup of tea would be the Y valley. So this is where along the grasp, if the blade was perfectly straight, where along it would it be, 0 to 1? So this helps us remap that into a ZY. So it's going to simulate basically, so if the Z is that way and the Y is that way, how much would it, along those two axes, basically, right? So now you've got your new Z. So ZY, Z, YZ dot X, which is the Y, and then YZ dot Z. Ta-da. So I think that's it. Bit fiddly, but I think that's... So 140, it's not liking that one. Why like? What's going on? Hmm. What are you complaining about exactly? Syntax error, unexpected identifier. Which one of you is an identifier? Which is unexpected? Right, I'm just going to take a quick break. BRB, just going to get another drink. But yeah, any questions, feel free to ask away. BRB. Hey. Is Vec1 such a thing? That's probably the issue, right? Did I accidentally decrement too much? Yeah. Oh, Vec0 even 0 dimensions. Thank you for that. I think you found it. Right. Yeah, I think in some languages, what is it? Is it HLSL? You can do like a float one, which is what you know. Yeah, I know in GLSL for a floating point value, you can say y.x. It works. I think you can because I've done it before. Anyways, wow, we've got something which is clearly buggered up, but it's kind of working fine. It just seems a bit. Right, so oh, hang on. We can do some debug stuff for this. We don't have to live in. Right. Hmm. Yeah, you're talking about the one which moves around. It's like a tumbleweed, right? Or oh yeah, so you're talking about a cat. Yeah, you're talking about a cactus, right? Yeah, I see it. It does, doesn't it? It's like old cartoon. Yeah. Drawings of cactuses or cacti is maybe the correct way. I don't know. English. But yeah, so we could debug draw this. It's not too difficult, right? Like, basically we take this code, right, and we simply do a thing. Right, where do we do the thing? We can do it in the grass vertex shader. We just say, right, if vertex, sorry, instance index, probably both actually, equals 0, and vertex index equals 0. I could have done this anywhere, but I found it here now. So we've got some debug drawing stuff. So I think we've got lines. Or we've got vectors, I think. I think I got a vector. So yeah, I don't think there's a lot of stuff. Vector, circle. Yes, we'll do circles. So circle, we'll do P0. So we need to do what space are you in, basically. So do the right, so P0, your radius that's a depth value, I think. No, it's not, is it? Where's that value again? Oh, like a border thickness. Oh, depth and border thickness. Yeah. Right. Then a color, so we'll just do red. Right, nothing called instance at the moment. So we can just hard code these to like 0. So we just do 1 for now. Then tilt, we'll just do 0 for now. Okay, so we can live with that. And the Y value, we'll just do 0.5. Right, so here's our thing right here. A little bit too big. So this is 0.0. We'll do a bit bigger for you guys, I guess. So we'll do the rest of them. So you got your point and 0.2. Okay, so my 0.2 is directly up. That's because I ain't got no tilt. So you notice how this one is to the left-hand side. That is obviously the one. We should maybe color this one blue so we can see, well, maybe not good color. What's another good color? What's a good one? Cyan, teal, magenta, maybe violet or magenta. Right, so this sort of magenta one over here, this one is that special point which defines the curve in, yeah? So these are the two end pieces, these red ones. So as we define more tilt, yes, that's as you would expect, right? Tilt 1 gets you a right hand, like here, but because we've got the, yeah, you notice that this value is not directly in the middle because I've done a 0.6 loop across these two lines. So we did 0.5. Again, this is diagonal and then up here. So that's cool. Now, if we take, say, this YZ thing and then try and plot it, we can do a whole time thing in a minute as well to see it move across the line. But let's give that maybe, let's just do, should we do pink? Do YZ. I see nothing. Yeah, this is not good. Right, so clearly we need to print this value out. So it's saying 0.1, 0.6. We should be seeing that on the screen. I don't see why we're not. Let's comment out these ones. Let's comment it out. Let's put it back in. Can't see it. Confusing. So, but we look at like P0, for instance. That's 0, 0. P1, a little bit of a minus. Right, that is a bit much. Right, okay, but if we go back to YZ, not anything too different. So why do we not see it? That's the question. Is the pink, pink is probably just wrong. Let's make it another red. Okay, so the pink value that we've got is not good. FF, CB, C0. No, I don't know what. With maximum red. Yeah, I don't know why that doesn't work. Weird. Maybe. Anyways, let's do violet. Oh, you see it? Maybe it's something to do with my HDR monitor. Is this one of those things? Yeah, I see it actually too. It's come up very white, hasn't it? Oh, the power of SDR. That's okay though. Thank you for that though. Appreciate it. How's it going, Saucepan Can? Right, so now we get to have some fun where we can just animate it. Right. Sine with G time 0.5 plus 0.5, so it's a value between 0 and 1, and here we go. Whoa. So yeah, that's the curve the grass will take. So the code seems fine. So maybe it's just the way we're defining it in local space is a bit wrong. So we can also do this time thing to help us with doing something like a tilt or the curviness. Right, but instead we're going to maybe multiply the time by 2 or something, yeah? Yeah, so as we move it close, see how the thing, yeah. Cool, okay. Right, nice. So we see it working, right? Absolutely no problems with what we've got here. So let's go back to the other code. It seems like then the way we're defining the Z or something is wrong. I don't know what we want to say it is. So yeah, it's pretty handy. Like they're one of the like if you can do it, you want to get printing. So just put all this stuff into storage buffers, right? Just from the fragment shader, or sorry, from your shader code, just write out to a buffer called like a print buffer or a shapes buffer, 2D. I got 3D one as well, and just simply draw indirect them at the end of the frame, basically. And so you can do all this stuff from on GPU. The one I want to try, which I didn't get a chance to do, is you do some UI. Like if you've got like your own immediate mode UI or ImGUI, do it ImGUI. You could theoretically like do the same thing, right? You send back commands to the UI from the GPU, and then feed those values back to, and all we need is just a tag like a number, right? Number one means this value, right? And it just puts into the one slot in the array. So it's the thing you could do. It's not an original idea. I've seen someone else do it on the internet. Hooked up ImGUI via on GPU. So send it back to the CPU to do the rendering, and then and the input logic. Hook up with proper ImGUI, and then send all the data back. It's cool. But yeah, I'm missing some 2D shapes, so we've had to make do with just circles. But yeah, I've got a lot more 3D ones. This whole floor that we're on right now, this plane is a debug plane, which is not part of the renderer. It's not a mesh. It's just a debug plane that's ray traced into. So yeah, I think it's obviously the way we're applying it here. Because the y value would be 0 to 1, and these are all correct. So this would again just be 0 to 1 values. So they seem to be arcing the wrong way. So if I were to mirror oh, for crying out loud, it's done that thing now, isn't it? Where it doesn't want to change my... Let's rebuild all the things. I need to fix my build system. But it's fine for now. Yeah, I think that's it. Ta-da! I don't know why, though, that's the wrong way. No, is that the right way? Hmm. I think so. Cool. So I think this is good. We can now obviously add more grass blades and stuff. So you might want to add a bit of a bend in the blade such that it never goes flat, or a bit of a twist to it. Yeah, it does look a bit odd. Yeah, this is all just random values, so we would... Yeah, so with the tilt, I don't think you really want a 0 tilt. And like... Yeah, so I think with the curviness, you don't really want it to push out that much if your tilt is not that much, right? So you could do a max, or I think... So if your tilt is 0 to 1, do you just combine it with tilt this way? I don't know. So if you've got curviness, 0.2 curviness, or say if you've got 1 curviness, but 0.2 tilt, that'll make it 0.2 curviness. Yeah. But I think at the point of you don't care about maximum curviness is yeah, I think that's what you want. That's fine. Yes, that would be better if we restart the program. I don't know why. Ocarina didn't work again. Yeah, so now if it's near straight, it's not allowed to curve that. Oh no, it kind of is. It's there, isn't it? That one there is a bit suspect to me. So we got rid of the curviness. See, it's kind of, oh, yeah. Yeah, maybe it should be times tilt 0.5. Cool. Right, that's all right. Yeah, I like that. So it's not really a value between, you've halved it that point. Um, so yeah, we'll say 0.5 times 0.6. Okay, of course, it's 0.3. Simple maths. So I think what we're looking at is a value between 0.2 and 0.5. That's what it is. Okay, that's really good. Cool. So obviously you want to have some kind of wobbliness, right? Like actually wobbling up and down. And tilt, to be honest with tilt, I really don't think you want tilt to be going into the ground either. So tilt should really be going up to maybe 0.8 or 0.75 maybe. And then you can add a bit of sort of wobbliness to it, if you will. Now, I don't know. Then these are 4-point cubic setup for Ghost of Tsushima, I think I heard in the video. I don't know. When I just watched it back just now, it seems like they only have 1 midpoint here.
Apart. This keeps them facing the same general direction while
Maybe
still
they add
increasing
it later
coverage.
for the animation, I don't know.
Now that we know where our control points are, it's straightforward to determine our world space position for our vertex. We take our 0 to 1 value that determines where we are along the blade and feed that into our Bezier curve function. Next, we take our facing direction, flip the x and y, and negate 1 to find a normal orthogonal to our facing. We step our vertex in the normal's direction a distance depending on the width of the blade, calculated in the compute shader, and scaled by where we are along the blade.
Doesn't seem
We
like
want to
it.
be influenced by the wind in the compute shader, so now we just do some simple bobbing up and down. This bobbing is a simple sine wave where the phase offset is affected by the per blade hash, as well as the position.
Where the face offset is, okay, so the face along the, yeah, so the triangle faces, if you will.
Along the grass blade to give the motion a swaying look. The per blade hash offset ensures each blade's motion is different. It's important to note at this point that the arc length of a Bezier curve is not very easy to calculate and hard to control. As the blade animates, the arc length definitely varies. However, if the animation is kept relatively constrained, this isn't noticeable.
Yeah, we've already done the rounded normals thing. That was quite easy. Did it in the shader. I wonder. So we kind of added that. You want it to like wobble, right? Now, for that, that's just a Z. They just did a sine wave, wasn't it? So yeah, we could just do. Uh, yeah, what do they call it in the end? Obviously, it's based on the Y, you know, how much is up the thing. Let's say that again.
To give the motion a swaying look. The per blade hash offset affected by the per blade hash. This bobbing is a simple sine wave where the phase offset is affected by the per blade hash, as well as the position along the grass blade to give the motion a swaying look. The per blade hash offset
The face offset.
our world space position. The field has a rather expensive one.
Are they simply just saying they changed the T value? I cannot think that's what it is. Let's give that a go. But I think that's not what it is, right? As a what plant? Right, yeah. Yeah, I think in the future we want to do like a plant system as well. So we want to extend this into a plant system. So this is just obviously the first bit. We're just doing grass. We're just testing out materials. This is why I went down this avenue. Sort of how if we did grass, would our procedural material system still work with that? The answer was very easily a yes. But yeah, we will, and also planned out doing it as a plant system as well. You know, defining because as I was writing a plan for this, I was like, hang on a minute, you could quite easily do plants, like procedural plants, and even trees. Trees would obviously be a bit more complicated, but yeah, then I want to go back to materials next stream. To capture the movement along with a deep water wave. Huh. Oh, I see. Right. Yeah, yeah. Yeah, I'm not sure if this is what it is, but I just want to see what it looks like anyway. It just grows. Yeah. It's just it becomes a dolphin grass blade coming out of the ground and into the. Yep. Okay. It's obviously not it. Yeah. Well, yeah, so I think it could be this sort of Z thing. It's obviously wrong. Now we have moving grass blades. They're alive. So it's kind of like a bobbing thing, right? You just want to sort of move the tip. So that's just P2, right? So are you just changing tilt angle? But then you kind of also want it to sort of like move throughout the thing as well. So I think what you're saying is as your Y is different, change P2. Yeah, use that as part of the offset into changing tilt angle. Is that right, tilt angle? Yes, I think you could say with tilt angle, like add maybe like a sine with Y, like Y is 0 to 1, isn't it? So Y plus a bit of time. Yeah, that's sort of it. No, it isn't. It sort of is. It's just way too much. So you do and then you want to make sure you multiply time by something a bit faster. Now it just looks like a snake. Just gonna... It's gonna attack. It's the praying snake. Yeah. Like, so we made it more, like faster and more movement. How would that? Do we make it break? We made it break. Yeah, so obviously faster was a bad move. So yeah, it just depends on like the and then he was saying there's this sort of like per blade hash thing as well, right? So we don't really have. You might want to pass in like an instance index as well. But then you got to make sure then all your grass blades always have the same instance index. Oh no you don't. Yeah. So you pass in an instance index. Oh, do we still have that? Yeah, we do. So in the shading pass, we still have it. And in the vertex pass, we have it. So it would just be some kind of like seed or whatever. I don't know how you do that. You would probably say, you could throw into PCG hash, I guess. Then just divide it by like some big number. Then, right, it's just be like your seed, if you will. Now, I'm not sure, like, in some kind of types, they're all a bit different, so they're not going up and down together. No? I need to restart since... Yeah, so now they're not all swaying together at least. Some of them are though. I think it's because what you probably want is some kind of like smaller valley, maybe. Yeah, let's just say times by, I don't know, like 16 or something. There we go. So they're all different intervals there, which is kind of cool. And they're they look a little bit snaky, and they're a little bit too fast, right? So we're not really getting a wobble like we hope. We're just sort of getting more of a, it's more wobbly near the tip. Right, it doesn't really look that nice, basically, is what I'm saying. But maybe it will be fine if you have more grass blades. We'll do more grass blades in a very, very short while. we'll just finish up on the wind. So we're changing the tilt angle. That's one way of doing it. Think it looks good already? Yeah, I guess maybe it is fine. I'm just looking here, maybe. Yeah, we could just stick with it. Yeah, right, let's just make it filled with grass blades. So let's go to the emit shader. Now, what the emit shader's doing is it's just emitting one inside of an 8x8 grid. So you'll notice in the bottom left of the grid, it's just sticking a blade, basically. Right. Not that smart. That's all it's doing. So we could just get it to emit one in the middle and that will double it. You know? So we could just put it, or we could just put it into a function rate. You know, this is not really something we're gonna keep. It's just like so I can hot code reload it. So emit, I think we'll pass in the state. I don't know what else we'll do really. Oh, we'll obviously need the DST coordinate and is it really? All right. Oh, and the segment ends. Well, those could really just be passed here. So segment ends just define like how far up the vertices go along the grass blade. Nothing fancy. So ivec to DST chord, and then an in-out state variable. Okay. So DST chord, we could turn that into a floating point, and then basically just do a plus vec2 0 0 0.0 f 0.0 f, yeah, and then you just well, just need whole. Right, let's just do a 2 and a 2. Right, we got a slight issue. This one's complaining. It doesn't like something. Oh yeah, because this is a okay. We need two things. Uh, we'll call it an offset, I guess. Hmm. What happened there? That kind of changed things. Ooh. Are we outputting? Oh, yeah, we're overwriting. That's not good. So, yeah, we can't do that. We've got to do something else. We'll have ourselves a we'll have a stride. Wait, we're atomic adding. So it's just this. Ta-da! Right, so we can then... Right, so the issue is it's kind of put it on onto another one, so I think we want... 0.5 is probably what we want, actually. There we go. So we can now do... And then... Cool, grass blades. Ta-da! They look a bit bright. That's because the sun's like stupidly bright, I think. But yeah, I need to sort some of this stuff out. I don't know why I can't see the sun anywhere. It's probably off in the... Anyways. Yeah, we could fill up with more. So we could do a... We could... Alright, here we go. 2D. Y equals 0. I've already got this as a 4 range of an ice. So Y 0, 4. Let's just do a 4 by 4, yeah? That'd be x divided by 4, point F, y divided by all the grass blades. It's quite a lot of grass. But there we go. It's oddly emissive, I think, the grass. I think what doesn't help is this plane at the bottom is not really rendered along with the shading pass. But yeah, it would be nice to maybe put a bit of bend in the grass as well, to be honest. That would be cool. But we don't really have a vertex in the... It looks like a sea of... Like a sea at the moment. It's like, whoa, the way it waves. Yeah, I think what they talked about in Ghost of Tsushima as well is the way grass works in real life is it clumps, right? It kind of stems from the same place and it clumps together. So you want to create clumps and that will make it more realistic, right? Rather than stuff being sort of offset, you would typically clump it. Well, to be honest, we could clump it here, couldn't we? Really, what we're actually looking for is just you just do this, right? You don't even do an offset. Maybe you do, but just a smaller one. So then you bring your comps in a bit. Uh, there's been like 16 all out of the same area, all out the same. Maybe it's a bit too much, but you maybe can add like a scale as well. Hmm. Bring them a little bit closer. You got too many. Oh, hang on, that XY is just... Yeah, that was not right. We should have done 0, 0 there. That's part of the problem. Yeah, 3 points. Yeah, quadratic, that's right. Yeah. Yeah, I wonder if you could just move the midpoint in a way. Anyway, stuff to play around with in the future. It doesn't have to be perfect right now. Don't think we need an offset anymore. Um, there we go. I think that looks kind of alright. You could add more, but it's clumped them together now. Here, you can see it's clumped them. Looks a bit better, I guess. But yeah, I reckon... Yeah, there's a lot more better things we can do. I think we can make the way it animates. Yeah, I think you need to animate the clumps together as well. So there's those things. Wonder how 4 points would look like. Yeah, you would just... It just depends what you're using the fourth one for, right? Because all of 4 cubic Bezier is... Sorry. That's the way of saying it. So when you've got a quadratic, you've just got 1 point. So a quadratic is just like having a cubic, but you put both of those points in the same place, right? When you put them in 2 different places, I guess you can get curves that look like that, right? But then, so you just will have the possibility to make grass, which looks like this, which I don't think is what you want. What you want is simply just a single curve. Now, how you make it look wobbly on that curve, right? Like over time, like move it. That's probably a bit too wobbly. But you want to somehow somehow do something like that along that curve. What do you do? Um, so that would be that's not really the Z, is it? Oh, that normal. Oh, wait, I think I got it. So that normal that you had, right? That normal. No, we didn't have that normal. We have the line, isn't it? The old line it used to be. We have that normal. But you need to somehow basically like again the normal. They had that face where they figured out what face they were on, get the two, and Yeah, we need to figure out normals as well. But yeah, I think you can get a better, rather than doing it based on the just moving the endpoint. Currently, we're just moving the endpoint up and down. Basically, that's all we're doing, and it's sort of creating a wiggle. But maybe that's the way to do it. I don't know. Cool. I think that's reasonable. I don't know what else I want to do with this at the moment. Yeah, I think let's commit that code, and then we can prepare for next stream. So on Friday, so it's tomorrow, 2 p.m., we want to go back to doing materials, right? We've already done a brick material, we've done a moss material. I want to do, so here's the moss material, right? It's not, like, it's 3 spheres, sort of like, and then a noise applied on top, and then some coloring. I'm thinking though, we want to try and make these things apply on like every surface we can. So I'm thinking of ways how we can do that. Right, no worries. Yeah, so we're gonna still be exploring. We're going back to the. Oh, and obviously in the background we have a brick material, right? Ta-da. So I want to try and do dirt, stone, rock, maybe some gravel. I don't know. These sorts of things. Because we want to be doing terrain, right? So I also want to try and maybe we can make some sort of like grassy ground where it's like not necessarily manual blades rendered like this, right? So for instance, maybe you have a zoomed out camera or something. You want to have some sort of like very low grass. So it's just noise, right? That kind of looks like grass, right? Not necessarily big, thick blades. But, and then you have this moss one as well. So I want to be playing around with like getting a cube, texture in it with a procedural material again. And yeah, just really finalizing this stuff before we move to actually go and do the mesh system, right? Because we want to get some terrain down soon. So yeah, the plan is materials, terrain, plants, plant system, and then probably do. Oh yeah, after we have those things, we can basically, generate some kind of like landscape that has stuff in it, right? And that would be pretty cool place to get to. And then from there, I don't know what we would do. We could do lighting or we could do characters and stuff. I don't know. We'll see. Or some editor stuff. You know? It's all. Yeah, so let's just go and get a cube back up. Let me just quickly do some. I don't want it to like give stuff away, right? So I've done a commit, just called it grass in it. And so we're on day 39. Let me take that up. Nice. Cool, so that's all just checked in now. Well, no, it's committed. I'll push up to the code base later. But yeah, for those who want to support the channel, get access to the code, there is a link there. And thank you for everyone who's supporting, by the way. Appreciate you all. Yeah, so for now, we're just going to go and sort out I want to bring back the mesh rendering stuff. I don't know what I did with it. Graphics VK. I'm not going just yet, by the way. We're still here. We're just going to prepare for next stream. Yeah, it said a bit more about 4 points. Yeah, you should see, you know, it's just comprised of like lerping, isn't it? Right? But yeah, you just don't really want 4 points for grass. Right, so we just put out this one. How does that look? Because we broke it, I think. Get this one. The grass emit, are we just going to disable that now? Yeah, just don't render grass. I think that's basically it. Just disable rendering grass for now, but because we've tested it out and we're happy with the results. So when we draw a cube, we should destroy the plane now. Get rid of that plane. Right, let's bring back the cube. Oh yeah, I forgot we got stars in the thing. I forgot we put those in there. It's alright. The nebula as well, if you look close enough. Anyway. What do I want to do? I want to go to the game, the orbit cam. Let's bring it closer. Excuse me. There we go. So, what's going on with this this cube, shall we say? The scene shade, we kind of messed it up a bit, right? The UV, we don't already have a UV. So, like, how do I get one of those now? Yeah, I think we want to just bring in that Rayverse box thing that we had before. Border box, we deleted it, we'll bring it back. The draw 3D fragment shader has some stuff. We just took it from here. This is just the debug drawing. This is the one. So in scene shade, we'll just do reverse this thing for a minute before, whilst we don't have any meshes. And then so it's got a normal on it as well, I think. Do we just want what's the ray? Wait, we can calculate the hit position and then vehicle we have a normal. How was we calculating the UV before? Can I get diff head up or something like that? Is that what you call it? Get diff head. Oh, it's -1. Oh, it's like this not thing. Great. Anyway, so it's something to do with the Yeah, so we took that code out and then right, the normal is that, how do we calculate the UV again? Right, position local space, obviously. Right, so we don't really care about the normal, I don't think, in this moment. We'll just do T. So, what was it again? Ray origin local space, ray origin, sorry, ray direction local space. Ah, right through. Yep, then infinity for the border. Now you got T, so it's T. Then it's position local space, which ends up being, come on. Oh yeah, it's this guy, isn't it? So I'll take you, please. This should get back the brick, I think. I forget. Hmm. And to get the epsilon. Oh, that's a big fail. Right, so there's the brick. Kind of though, like I don't get why it's looks like a toy. Like a cute little toy. Are we like I think the UV, if we look at the UV, I think it's not that great. I think the UV is hmm. If is mouse out, let's get this one. Yeah, 0.5. So I think we ended up timesing the local space by 2. There you go. We're back. We're back. Yeah, so now we can test these things out again. So they've got these. Yeah. Cool. This is going to be amazing. Looking forward to that. So I think we'll start off by getting the. Where's the game? Would actually like to probably put the instance. Hmm. Sorry, mesh cache alloc. That's the one, isn't it? Yeah, so let's just put it directly in the middle, and we're orbiting around the middle anyway. Yeah, so now I've got an orbit cam around it. Nice. Like that a lot. We could make it bigger, like, so we scaled it. Scale, is that a thing? Yeah, so, uh, let's scale it up by 4, but then in game we'll have to back to at least 4, I think. Bit more. There we go. And now we can zoom in a bit more closer without it clipping. Well, we could just go to 10 and boost it up to 8. So we can get even closer now. Without it clipping. Lovely. Cool. This is great. So we can now. Yeah, so next stream, this is just a cube, right? And then we're ray marching into it to get these sort of brick looking things. And the brick is customizable, it's got like different parameters. This is one we made in the past. But we want to try doing like dirt, you know, like a soil, basically, like an earth. We want to try and do stone, rock, that sort of thing, more natural, landscapey materials, basically. And then try and combine them, right? In some way. There's a way we could lerp them as well. But yeah, we want to like try and nail this material, this 3D material thing, before we could move on to doing meshes, basically. So I'm glad we've managed to sort out, like we're doing grass and foliage and plants. We've figured out that this system will work with that. It's kind of obvious in retrospect, but it's good to know. And I will keep that system in mind whilst we're coming back to here. Anyways, I think that's it. Yeah, you're gonna come out, hang out in the meantime, there's a Discord channel. And thank you for everyone who supports the stream. There is a way to support the stream and get access to the codes for running your own local machine. I'll be on tomorrow, 2 p.m. GMT +1. Timeline is down below. And there's a stream on Sundays, Tuesdays, and Thursdays as well. But yeah, that'll be it, guys. I'm gonna try and. No worries, sir. Yeah, I'm gonna try and calm down before bed and then crash out in bed. Super tired. But yeah, thank you for popping by, guys. I'll see you all in a future one, hopefully. But if not, have a good weekend if I don't see you tomorrow. All right, God bless you all. Bye bye. Boom.